Sup homies, my name is Mike S, and I built an LLM from scratch. Now you're looking at it, it's running on a local port. I leveraged the weights in the architecture that OpenAI open sourced in 2019. So you guys will see at the end of this video what the results are in terms of how it predicts text. In order to get this far, I followed a tutorial. I'm gonna post all the links in the description, but this gentleman named Sebastian created a tutorial for building an LLM from scratch. It's fantastic and incredibly eye-opening. And I want to share with you guys exactly what some of my learnings were, and then we'll play around with the agent at the end of the video. So if I had to break down the problem of creating an LLM from scratch, I would kind of put it in 4 buckets. The first bucket would be to create a vocabulary. Now, mind you, this is all coming from Sebastian's tutorial, so I didn't think outside the box in this regard. But if I had to kind of break down what he said, I would say there's 4 kind of buckets. You create a vocabulary for the model, right? What can the model draw from if it's going to generate text? Then you need to, specifically for training and developing the weights, you need to instruct the model how it should divide its intention, because translation is not simply a matter of taking a word and then translating it to a different word. You have to, the context for how that word appears is fundamental to the ability of a proper translation to occur. So I would say that's a second bucket. It is in the architecture. They're called attention heads. Then the third bucket, and this is by far the most important, is training the model. And this is where OpenAI gathered their bread. This is their money. After the model's trained, you generate the text. And we'll show you what that looks like in a bit here. So what is it doing? Like, how does you may have had this situation that I had, which is, out of nowhere, you use OpenAI or ChatGPT for the first time, and you're like, wow, how is it able to do this? At the most basic level, these large language models take into context what's featured in blue here in the image, and it generates a target. That's at the core what it's doing. Now, after it generates a target, it feeds that new context back into the model, and ultimately you're able to produce full thoughts or a set of tokens. Now, at a more granular level, when we're talking about like how the software manages the vocabulary, it does a token matching. So for every token in your vocabulary, it has a corresponding ID. And so what you'll see when you're going through this architecture, a lot of what the software does is it does a lot of encoding and decoding, because it doesn't speak English, right? This is just software we're talking about. So you have to prepare or decode, or encode the English words into a language that the computer is able to understand. And I would say that's at the crux of how these LLMs work. And this image that Sebastian provided, I think, was so important for me to even get a grasp on what's happening with these large language models. But we'll just go through it because I think it's illustrative. So we start with input text, in this case, hello, I am. It's encoded into these token IDs. Then the model takes in the token IDs, generates a logit or tensor. And from that tensor, it goes through a step of decoding into the context. But ultimately, that's what the model produces. It produces these large vectors, what they call logits, which is kind of, maybe a subset of vectors. And within the vector, you have a set of columns. For each, the number of columns is equal to the size of the vocabulary. And so if you have, for any index, a high value, that's the value that's going to be selected to be decoded into the final output. But this, I think, when I was going through this LLM architecture, this was the slide that popped the most. At the crux, right, like at the very core, what OpenAI has provided and what they offer are the weights for this architecture. That's what makes everything happen. As I showed in the previous slide, you select, and this is kind of a novel or basic or dumbing down a tad, but fundamentally, the model is going to select the index of the position with the largest value here. And how it gets there is based on the weights. And someone could correct me in the comments, but going through this from scratch, this is kind of like the main takeaway that I had. And so the weights are kind of the weights that OpenAI open sourced in 2019 that recently did here in 2025. These are kind of this is what OpenAI's bread is. And this was a big news story. Just a couple of weeks ago, we got two of the weights open source from OpenAI, the 120B and 20B. 20B, both of them you can run in Ollama, and I've done it. So it's a really cool exercise to be able to use these open source weights, and they're pretty good. Like you're not going to get the same results as maybe you'd expect with GPT-5, but it's definitely, because it's open source, definitely worth the look. Now, as I was saying, the model, the architecture that I showed you at the beginning and that we're going to play with here in a second, this is using the open source weights from 2019. And there were a group of weights that you can still have access to that I cloned from Hugging Face and assigned in my model. But they vary from small to extra large, and you can see that the small model has somewhere over around 120 million parameters, and the large model has well over 1 billion. Now, when I was going through this architecture, when I was building this LLM from scratch, what stood out to me was it felt like a bit of a cheat code to import the weights, because at the time I didn't understand. Coming from a software engineering background, I kind of thought this was a little bit of a software problem, but really the problem they solved is well beyond just coding up functions or classes or anything of that nature. It really comes down to how do you produce these weights that actually have meaning and you're able to evaluate and fine tune. And so I thought this was a great piece of data that Sebastian provided. The cost to produce the weights is so substantial, in the hundreds of thousands. So he uses an off-the-envelope calculation, and he says that it would cost somewhere around $690,000 to produce these weights for Llama 2. And I thought that was really illustrative. There's in the code in the GitHub, you'll see that there's some code for training, but the final weights used were not generated organically. They were imported. Now, this brings up another just phenomenal question, right? Which is, okay, so their bread is these weights. Well, how did they get these weights? And it turns out that for GPT-2, the architecture we're looking at, this is something like common knowledge. It's not completely exposed. You can, with a little research, find somebody who reproduced the training data. And by the way, real quick, on Hugging Face, most models you interface with, they do provide the training data. But in this case, we just know that they called it web text. It was about 40 gigabytes. And get this. The text used to train GPT-2 was scraped from outbound Reddit leaks. And so what they did was they found posts that had a high karma score, because basically it's like a human aggregating, good pieces of data. And so they found outbound links that were generated from folks who had high karma values, and then they programmatically scraped those links. And that formed what was called web text, and ultimately the 40 gigs that were used to train this model. Just a few other pieces of information regarding the Reddit links. Just by collecting the URLs, you get this human curated subset of the web. All right, so that's kind of the background of the architecture. It was a quick view, but let's actually see how it works. So I've got Skynet up here. I'm going to start by demoing what the inference is on this prompt. Now, some important things to keep in mind, and I don't know if this is 100% accurate. They open source the architecture, they open source the weights, so this must be how GPT performed in 2019. But you can see what this is able to do compared to what GPT does now or has been able to do in the last couple of years is a pretty substantial difference. You're not just gonna be able to put any prompt in here and get an inference, but let me show you what it can do. So using the small weights, I'm putting in this context, a little blurb about Apple and the iPhone, and we'll hit inference here. And we'll take a look and see what the generated text looks like. I had run it priorly, so that's why you do see the previous result. I imagine they're going to be different, but we'll have a look, and then I'll show you the output from the large model. So here we go. So the context ends here, and then we get this blurb that's generated. The MacBook Pro and MacBook Air come with the same AppleCare policy, including something like gibberish, but kind of on brand, I guess, talking about the monthly plan. Now let's look at the large model, the extra large model. So here's the inference on the extra large model. So it ends at, and they are substantially different from a magnitude or parameter perspective. This is where the context ends. And what we get, the inference we get from the model is it later received wide adoption worldwide. So a pretty coherent thought here. But still, you could see on the small model, actually the first inference I ran on the small model wasn't too bad. The second was kind of not quite gibberish, but on its way. But you can see the ability to get good inferences on these early GPT models was not fantastic. So now I just want to show you what it looks like without training. Okay, so I've got the Jupyter notebook. If you go through the tutorial, this is what you're going to work out of. I actually put it in the GitHub repo and put the Streamlit on top of it, but you'll be working through a Jupyter notebook. And so here's the same prompt or the same context. It ends in at the time, and let's see what it generates. And so using no weights or barely trained weights, you get this output: watch, dice, dummy, FO, treacherous grades. So it just generates gibberish. It can still generate text, but it's not at all sensible. All right, homies, if you like what you see, if you like what you saw, if you have any questions, if you can add to kind of this, what I did here, I'd love to hear about it in the comments. I create content related to AI engineering and software engineering. I also stream on Twitch daily. If you want to join us, it's an awesome community. So I'll leave all the links in the comments below. Thank you guys so much. Have a good day. Peace, homies.